Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Mohamed Sa with you, physics teacher. Now we're going to solve Moasser questions on universal gravitational force. Chapter 2, lesson 1. Chapter 2, lesson 1. Universal gravitational force. Okay, page 79, version 2020. Okay, multiple choice questions. Number 1, the question said that if the distance between the centers of two bodies is doubled, okay, distance d2, the new d equals 2d, and their masses are kept unchanging. M1 equals M, M2 equals M capital, for example. They are not changing. The attraction force between them will be, so F2 equals what? The new force between them equals what? Okay, before changing, force equals what? G capital M over D square, D1 square. The new force equals what? F2 G capital. M doesn't change, so M small, M capital, they are kept unchanged. Okay, but D2 equals what? 2D or 2D1. 2D1. So we can replace D2 to D1 all power 2. So F2, the new force equals G capital, M small, M capital over 2 square 4, D1 square, D1 square. This magnitude is F1, so we can replace, so F2 equals 1 over 4 times F1. So the new force is quarter the first force. So the attraction force between them will be quartered. The answer is C, quartered. Okay, the next question. Okay, question number 2. If the distance between the centers of two masses decrease to its half, the distance d2 equals to half d1. The force attraction between them, so the new force equals what? Before changing the distance, F1 equals G capital, M small, M capital over D1 square. So new force F2 equals G capital, M1, M2, they are not changed, but D over D2 square. So F2 equals G capital, M small, M capital over D2, by replacing D2 by half D1, all power 2, which equals G capital, M small, M capital over 1 square 1, 2 square 4, D1 square. So 4 can be placed at the numerator. 4 G capital, M small, M capital over D1 square. This part equals F1, so F2 equals 4 F1. Because by decreasing the distance between the two bodies, what will happen? The force will increase. So the force increases by 4 times. So the true answer of question number 2 increases 4 times. P increases 4 times. هتزيد 4 أضعاف. Increases 4 times. Okay, question number 3. Question number 3, two similar poles. Two similar poles mean M1 equals M2 equals M. Two similar poles, question number 3. M1 equals M2 equals M, for example. two similar balls, each of mass m and radius r, placed in contact to each other. Contact to each other, each of radius r and r. So the distance between them 2r, right? With contact to each other, then the gravitational attraction force between them is given by the relation, the attraction force between them. So F equals what? G capital, M1, M2, and M1 equals M, M2 equals also M over D square. Okay, F equals G, M times M, M square over D 2R, 2R, or power 2. So G capital M square over 4R square. So the true answer is B. Is B. Okay. Question number 4. Question number 4. Two balls of mass is 8 kilograms in one equals 8 kilograms. M2 equals 20 kilograms. The distance between their centers is 0.2 meters. R equals 0.2 meters. If the universal gravitational constant is G, so the attraction force between them, if the mutual force or attraction force between them equals what? F equals G capital M1 M2 over R squared. So F equals G capital M1 equals what? 8 times M2 20 over R squared 0.2 square. 160 over 0.04 G. So F equals for G 4000 G. So the true answer is B, 4000 G. 4000 G. Okay, the next question. Question number 5. If the distance between the centers of two identical poles, which means M1 equals M2 equals M, okay, is 1 meter. So distance for R equals 1 meter. And the force of attraction between them is 1 Newton. F, the mutual force between them, 1 Newton. The mass of each one of them equals, okay, by substituting F equals G capital M1, M2, M times N, M squared over R squared. So F equals 1. G 6.67 times 10 to the power negative 11 M squared over 1 square. So M squared equals 1 over 6.67 times 10 to the power negative 11. So by square root to the two sides, M equals square root 1 over 6.67 times 10 to the power negative 11 equals, using the calculator, square root 1 over 6.67 times 10 to the power negative 11 equals 1224443.87. So we'll choose from the choices, we can move this decimal point 1, 2, 3, 4, 5. So we can write it 1.2 times 10 to the power 5. So the true answer, or 1.22 times 10 to the power 5, the true answer is B. The true answer is B. Okay, question number 6. The ratio between the universal gravitational constant on the Earth's surface to that on the Moon's surface. G on Earth over G on Moon. It's called universal gravitational constant. Universal gravitation means 6.67 times 10 to the power -11 over the same number. So the ratio equals 1. Okay? Because it is general gravitational constant. على عكس G يعني G on Earth over G on Moon greater than 1. G on Earth differs from G on Moon. Like while general gravitational constant on Earth, on Moon, on Jupiter, on any place on the universe is constant. G equals 6.67 times 10 to the power -11. Okay, so the true answer is equal to C. The true answer is C, equal to 1. Because G on Earth equals G on Moon. G capital on Earth equals G capital on Moon. The next question, number 7. Question number 7. Two bodies of masses M1 and M2 and the distance between them is R. If the mass of the first body is doubled, mass M1 to M1 dash, for example, is doubled, and the distance between them is also doubled, D2 to D, or 2R, you can say 2R. The force of attraction between them, if equals what? Okay. F1 equals G capital M1 M2 over R squared. F2 G capital M1 to M, and M2 remains as it is over D2 equals 2R all power 2. So F2 equals 2G capital M1 M2 over 2R squared, 4R squared, cancel 2. So F2 equals half G capital M1 M2 over R squared. It is F1, so we can replace it. So F2 equals half F1. So the attraction force between them decreases to its half. The true answer is C. Decreases to its half. Decrease to its half. Okay, the next question. Question number 8. Okay, question number 8. In the opposite figure, if the car is moving with uniform velocity away from the traffic lights, you should know that the car moves with uniform velocity from traffic lights. Okay. Then what is the best graphical representation that represents the change of gravitational force F between the car, the force between the car and the traffic lights with the time as time passes. So it moves away from the traffic light. So you should know that the force will increase or decrease by increasing the distance between car and traffic lights, by increasing the distance. So the force F is inverse proportional to square the distance. You should know that. So the force decreases. So we can remove or examine C, and C is wrong, okay, because the force decreases as time passes. So we have A, B, and D. A, B, and D. Also, D is removed because the graph D force and reciprocal of time. Reciprocal of what? Of time. So C and D are exempted. Now we are going to choose from A and B. A and B. What is the difference between A and B? And which is the true one? Okay. Okay, what is the difference between A and B? A said that the gravitational force or attraction force between the car and the traffic lights decreases. Also, B say that decreases, but the force in this case decreases uniformly. By increasing after 1 second, the car moves with uniform speed. You should know that. So after 1 second, the car will be at this place, and after another 1 second, the same displacement. So if the car moves, for example, with a velocity 10 meters per second, so after a second, 10 meters, another second, 20, another second, 30, another second, 40. So the gravitational force at this time, F, is inverse proportional to the square of this distance. So, for example, 1 over 100, while in this, after another 1 second. So, if over 20 square, 1 over 400, the gravitational force decreases by 1 over 400. The next one, 1 over 900, and so on. So, the force decreases, but with non-uniform magnitudes. In the first second, decreases to 1 over 100. In the next second, 1 over 400, 1 over 900, and so on. So the true answer is B, because the force decreases, but with non-uniform way. The force at the first second, say, for example, 10. The next second decreases with larger magnitude. بتقل بمقدار أكبر. يعني هي بتقل في الحالتين بتقل، بس هنا بتقل بمقدار منتظم. This force decreases with uniform magnitudes. يعني بعد ثانية هتبقى مثلا 10، بعد ثانيتين 20، 30. لا هي مش بتقل كده، ده هي بتقل because it is the relation between force and displacement is inversely with the square of the displacement or the square of the distance between the car and the traffic lights. So the true answer is B, because the force decreases but in non-uniform way. But A, the force decreases but in uniform way. 10, 5, for example, or 20, 15, 10, and so on each second. So it decreases with equal, but in this case it decreases but with non-uniform way. بتقل بمقادير غير متساوية. So the true answer is B, because the force is inversely proportional to the square of the distance between the car and traffic lights. So the next question, 9. Question number 9. Two asteroids, one with a mass of 7.12 times 10 to the power 18 kilograms, and the other with mass 5.33 times 10 to the power 8 kilograms. And the distance between them is 10 times 10 to the power 10. What is the gravitational force on the larger asteroid? Okay, as two asteroids. The first one, 7.12 times 10 to the power 18 kilograms, and m of the larger one, smaller one, 5.33 times 10 to the power 8 kilograms. This is the larger one, and this is the smaller one, and the distance between them 10 power 10 times 10 meter. What is the gravitational force on the larger asteroid? Okay, we said that the force between them, the gravitational force between them is a mutual force. يعني قوة متبادلة. يعني this planet attracts this asteroid by a force F, and also this asteroid attracts the other asteroid with the same force. It's a mutual force between them. So F greater asteroid greater هي يا F smaller asteroid equals F. So F greater, which equals F, G capital, M small, M capital over D square. Okay, M1 G 6.67 times 10 to the power negative 11 times 7.12 times 10 to the power 18 times 5.33 times 10 to the power 8 over distance 10 times 10 to the power 10 or power 2. Using calculator, F equals 6.67 times 10 to the power negative 11 times 7.12 times 10 to the power 18 times 5.53 times 10 to the power 8 over 10 to the power 11 square. 0.0 2531 Newton. We can 1, 2, 3, 4, 5. 2.53 times 10 to the power negative 5 Newton. So the true answer is C. So طيب هو الكريتيكال ثينك هنا في ايه؟ هو عايز يقول لك what is the gravitational force on the larger asteroid؟ هي الفكره كلها في كلمه larger asteroid. نقول له والله larger asteroid هي smaller asteroid. يعني this asteroid attracts this asteroid by a force 2.53 times 10 to the power negative 5. Also the smaller asteroid attracts the larger asteroid with the same force. يعني ده بيشد بالقوه دي وده برضه بيشد بنفس القوه. خد بالك the earth attracts me with a force 800 نيوتن. الارض شدني بقوه 800 نيوتن. انا برضو شادد الارض ناحيتي باي فورس 800 نيوتن. احنا الاثنين شادين بعض بنفس القوه. اوكي، اتس ا ميوتشوال فورس، قوه متبادله. اوكي، question number 10. A satellite orbits the Earth at distance 100 kilometers. A satellite orbits the Earth at a distance 100 kilometers. So distance could vary. Distance between satellite and the Earth's surface equals 100 kilometer times 10 to the power 3 meter. You should convert it into meter. The mass of the satellite 100 kilogram. Mass of satellite equals 100 kilogram. While the mass of the Earth is approximately 6 times 10 to the power 24. Earth 6 times 10 to the power 24 kilograms. And the radius of the Earth, you should know that the radius of the Earth R equals 6.4 times 10 to the power 6 meters. What is the approximate gravitational force that acts on the satellite? Okay, it is a mutual force between the Earth and satellite. So F equals what? G capital, M satellite, M of the Earth over distance between center of the Earth and satellite. So we can say that R, radius of the Earth, plus D all power 2. Substitute G 6.67 times 10 to the power negative 11 times mass of the satellite 100 times mass of the Earth 6 times 10 to the power 24 over radius of the Earth 6.4 times 10 to the power 6 plus D 100 times 10 to the power 3 or power 2. Using the calculator, 6.67 times 10 to the power negative 11 times 100 times 6 times 10 to the power 24 over bracket 6.4 times 10 to the power 6 plus 10 to the power 5 all power 2. The attraction force between them 947.21 Newton. Okay, the true answer 9.5. We can move this decimal point to this place, equals 9.47 times 10 to the power 2, right? 9.47 approximately 9.5 times 10 to the power 2 Newton. So the true answer is 10, the true answer D. The true answer is D. Okay, the next question. Question 11. Question 11. Two satellites of equal masses, M1 equals M2 equals M. Okay. Orbit a planet. Satellite B orbits at twice the orbital radius of satellite A. A planet, satellite B, satellite A. Okay, satellite B, RP equals to RA. Which of the following statements is true? The gravitational force on satellite A is 4 times less than. The gravitational force on satellite A 4 times less than. A less than? No, A is greater than the attraction force of A because it is much closer than B. The distance RA is less than RB, and F is inverse motion to R squared. So the attraction force FA is greater than FB, right? So the first one is wrong. The first choice A is wrong. The gravitational force on satellite A is 4 times less than. No. Also B, the gravitational force on satellite A is 2 times less than. No. We said that the attraction force between satellite A and the Earth is greater than. If A is greater than FB. So C, the gravitational force on the satellites is equal. No. Gravitational force on both satellites is equal. It's wrong. The gravitational force on satellite A is 4 times greater than that of satellite B. من غير ما نعوض في ارقام، هو طبعا الاختيار الصح هو دي. because هو الوحيد اللي بيقول لي gravitational force on satellite A is greater than. طبعا greater than by 4 مش ممكن تتاكد منها. حابين تتاكدوا منها substitute هتلاقي هنا هتلاقي 2 تحت 2 R A or power 2 تبقى 4 يبقى more than satellite B by 4 times. او B اقل منه بكوارتر يعني اقل منه ب4 اضعاف يعني اكبر منه 4 times. احنا مش محتاجين نتاكد منها. 12. A 70 kilogram astronaut floats at a distance of 10 meters from a 50,000 kilogram spacecraft. M astronaut 70 kilograms and the distance 10 meters. M spacecraft equals 50,000 kilograms. What is the force of attraction between the astronaut and spacecraft? F equals what? F equals G capital M astronaut M capital spacecraft over D square. F equals 6.67 times 10 to the power negative 11 times 70 times 50,000 over D square 10 square. Using the calculator, 6.67 times 10 to the power negative 11 times 70 times 50,000 over 100 equals 0.0 2 3 3 3 4. So by moving this decimal point 1 2 3 4 5 6 2.33 times 10 to the power negative 6 Newton. So the true answer 2.4, approximately 2.4 times 10 to the power negative A. The true answer A 2.4 times 10 to the power negative 6. Okay. Question 13. Question number 13. Two masses M1 and M2 are separated by distance d. What changes in the variables will result in no change in the gravitational force between the masses. يعني التغيرات اللي هتحصل دي الفورس تفضل زي ما هي. More than one answer is correct. في أكتر من إجابة صح. A M1 is doubled and D is doubled. أوكي تعال نشوف كده لو A doubled M1 doubled يعني M1 هنحط مكانها 2 M1. و distance also doubled D2 2D. F equals G capital M1 M2 over D square. F in this case F في الفيرست choice G capital زي ما هي، لكن M1 هتبقى 2 M1 و M2 زي ما هي، والدي هتبقى 2D all power 2 2 G capital M1 M2 over 4 D square equals 1 over 2 F1. So the new force Fa is half the first force, so it is wrong. Wrong answer. B. M2 is trebled and D is quadrupled. Okay. G capital. M2 is trebled. M1. M2 is trebled 3 M2 over, and the distance is quadrupled. D 4D all power 2. Okay. 3 4 square 16 G M1 M2 over D square. F1 3 over 16 F. So the force decreases. So it's wrong. Okay, C. Both M1 and M2 are trebled. G capital. M1 trebled. M2 also trebled. Over and R trebled and D is trebled. D trebled. 3D all power 2. Okay. 3 times 3 equals 9. G capital M1 M2 over 3 square 9 D square. 9 cancels with 9. So the new force equals 1 G M1 M2 over D square, which is equivalent to F. So the force in this case doesn't change. لأن الماس زادت، كل واحدة زادت 3 times والديستنس زاد 3 times بس سكوير، فبالتالي الفورس مش هتتغير بالرغم ان هم بعدوا عن بعض، بس الماس كمان زادت، فالديستنس زادت والماس زادت، يبقى ايه؟ C is correct. بس هو كان بيقول لي خد بالك you should know that more than one answer is correct. You should also be sure from D. هنشوف كده دي برضو بتقول لي ايه. D M2 is quadrupled. G capital. M2 is quadrupled. M1 زي ما هي، لكن M2 quadrupled. M2 over and D is doubled. D doubled. So 4 خلي 4 هنا 4 over 2 square 4 G capital M1 M2 over D square. F and 4 cancel with 4 equals 1. If so, the new force equals remains as it is. So the true answer is C and D. يعني دي هو عايز يقول لك لو دي زادت الضغط زود كل ماس 2 تايمز او زود واحده 4 تايمز عشان تبقى كده، او زي ما حصل فوق 3 و 3 وتحت 3 سكوير هتبقى 3 تايمز 3 وتحت 3 تايمز 3، يبقى كده ما عملناش حاجه. اوكي question 14. Question number 14. A block with a mass of 30 kilograms is hanging still from a string. If you place another block with a mass of 10 kilograms at distance 2 meters away, we have 30 kilograms and another block of 10 kilograms, and the distance between them 2 meters. D equals 2 meters. What is the gravitational force between the two blocks? F equals G capital M1 M2 over D squared. F equals 6.67 times 10 to the power -11 times 30 times 10 over 2 square. (6.67 times 10 to the power -11 times 50 times 10 over 4. F equals 0.1, 2, 3, 4, 5, 6, 7, 8, 5. So we can move the decimal point 5 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the power -9 years old. The true answer 14. 5 times 10, the true answer is D. Okay, the next question, question number 15. Mars orbits the Sun at distance of 2.3 times 10 to the power 11 meters. So D equals 2.3 times 10 to the power 11 meters. The mass of the Sun is 2 times 10 to the power 30 kilograms. And the mass of Mars is in Mars 6.4 times 10 to the power 23 kilograms approximately. What is the gravitational force that the Sun exerts on Moon? F equals what? F, question number 15. F equals G capital M1 M2 over D square. Substitute، يعني هي تعويض مباشر عشان ما تضيعش فيها وقت، ما فيهاش أي فكرة. 16. The moon has a mass of 7.4 times 10 to the power 22 kilograms and radius of 1.7 times 10 to the power 6 meters. What is the force of gravity experienced by a 70 kilogram astronaut standing on the lunar surface? برضه تعويض مباشر في نفس الرول، يبقى 15 16 هنكتب نفس الرول وسبستيتيوت بالارقام، مش ما فيهاش اي مشكله. نيجي ل 17. Critical thinking. The planet Jupiter orbits the Sun at nearly constant speed. Which of the following statements are true? Select the two best answers. أفضل إجابتين، يعني في two answers correct. There is a force on Jupiter toward the center of the orbit. There is a force on Jupiter pulling it out from the center of the orbit. طبعا A correct. There is a force on Jupiter, Sun and Jupiter. There is a force on Jupiter toward the center of orbit, toward the center of the orbit. right, a mutual force. So A is correct. There is a force on Jupiter pulling it out from the center of orbit. Pulling it out? No. B is incorrect. C, there is a force on Jupiter in the direction of its motion. There is a force in the direction of its motion. No, C is incorrect. There is accelerating towards the center of orbit. Yes, D also true. There is an acceleration because this force acts normally to the direction of movement. F or FG, gravitational force between Jupiter and Sun, is perpendicular to the direction of movement. So this force acts as centripetal force. So Jupiter acquired acceleration called centripetal acceleration that keeps Jupiter moving in circular path with constant speed and changeable direction. It changes its direction. So A and D are correct. Okay, the next question, 18. 18. 4 planets A, B, C, and D orbit the same star. And we have 4 planets. The relative masses and distances from the star, and there are 4 planets are shown in the table. For example, planet A has twice the mass of planet B and planet D. Planet A has twice MA, twice the mass of planet B, 2MP, and planet D. And planet D has 3 times the orbital radius of planet A. And planet D has 3 times, or D, 3 times the orbital radius of planet A, or A. Which planet has the highest gravitational acceleration, attraction to the star? احنا عايزين the greatest F. Okay. Planet A, relative mass 2m, and planet relative distance r. F A G capital M A M planet over D square or R square equals planet A 2m. Okay, by substituting G capital MA 2m times M capital of the planet over R relative distance or R squared. So FA, so we can say that FA equals 2 G capital M capital over R squared. FP, G capital MP equals M star over 0.1 R, 0.1 R all power 2. So by G capital 1 over 0.1 square M capital over R square, 1 over 0.1 square, 100 equals 100 G M over R square. So this number is greater than this number, that G M small M capital over R square, G M small M capital over R square. So FB is greater than FA. The force on planet B is greater than that of planet A. FC, G capital, MC 0.5 M times M star over distance to R square, 0.5 over 2 square G M capital over R square. Okay. 0.5 over 4 equals 0.8 Ft equals 0.125 g m small m capital over r square. Compare these numbers. Fd g capital m 4m 4 m capital over 3r all power to 4 over 3 square g capital m small m capital over r square. 4 over 9 0.44 g capital m small m capital over r square. So the greatest number is b. So the true answer is b. The planet B is the true answer. Planet B, because it has the greatest magnitude 2, 100, 0.125, 0.44. So the greatest number is the force acted on planet B. اوكي. هنحل بس في البروبلمز، ناخد الكريتيكال ثينكينج بيج 83 عشان بس الوقت، هو كده كده تقريبا تعويض مباشر مفيهاش مشكله. بيج 83 اخر مسألتين عشان تعبت بصراحه. page 83. Number 4, the question said that a 3 kilogram mass is located 10 centimeter away from a 6 kilogram mass. 3 kilogram mass with 6 kilogram mass. Is located 10 centimeters. Distance بينهم كام؟ 10 centimeter or 0.1 meter distance. كلها 0.1. What is the resultant gravitational force on a 2 kilogram mass located at the midpoint? في عندي 2 kilogram mass located at the midpoint، يعني distance دي equals distance دي. تمام؟ يعني 0.1 over 2. 0.1 over 2, 0.05. This distance 0.05 with this distance 0.05. Okay? السؤال بقى بيقول the question says that what is the resultant gravitational force summation F on this body equals what? Summation F, the resultant force, because there is a force in this side F1 and there is another force in this side, so summation F equals F1 minus F2. So we should get F1 and F2, then subtract these forces from each other. Okay. Midpoint of the line joining the first two masses, assuming that the masses behave as point masses. Okay. So we should get F1. F1 equals what? F1, it is mutual force between this body and this body. G capital, M body, say M1, M2, M times M2 over D between them, the distance between them, square. So F1 equals 6.67 times 10 to the power negative 11 times M, the body 2 kilograms times 6 kilograms over 0.05 square equals also F2 G capital M1 over D square equals 6.67 times 10 to the power negative 11 times 2 times 3 over 0.05 square. (6.67 times 10 to the power negative 11 times 2 times 6 over 0.05 square. This force equals 3.2 times 10 to the power negative 7 Newton. And this force equals 1.6 times 10 to the power negative 7. 1, 2, 3, 4, 5, 6. Okay, Newton. So summation F equals F1 minus F2 equals 3.2 times 10 to the power negative 7 minus 1.6 times 10 to the power negative 7. By subtracting equals 1.6 times 10 to the power negative 7. So the resultant force towards this planet, because it has greater mass, so the resultant force towards this planet, and this magnitude equals 1.6 times 10 to the power negative 7. Question number 5, the last question in this part. Question number 5, the center of the moon is 3.9 times 10 to the power 5 kilometers away from the center of the earth. From center of the moon to center of the earth. 3.9 times 10 to the power 8. 3.9 times 10 to the power 8 meter. You should convert it from kilometer into meter. The mass of the moon is 7.3. In moon 7.3 times 10 to the power 22 kilograms. The mass of the earth 6. In earth 6 times 10 to the power 24 kilograms. How far from the moon on the object are equal and opposite. يعني لو في جسم بين الاثنين خلاص يبقى على بعد كام. How far from the Earth's center an object is exerted. يعني هو عايز الديستنس من الاوبجكت لغايه السنتر. الديستنس دي بكام؟ اللي المكان فيه دوت from the moon the object from the moon on the object are equal and opposite. How far from the Earth's center an object is existed if the gravitational force on the Earth and the moon on the object. يعني F هنا equals F هنا. F between object and Earth equals force between object and moon. نحطه فين بقى؟ يبقى مكانه فين؟ Assuming the object is on the line connecting the Earth and the moon. يعني بقول لك ان الاوبجكت دوت على الخط اللي واصل بين التو سنترز يعني في النص بينهم. اوكي المعلومه البدائيه وده question number 5. The information F1 equals F2, right? F1 equals F2. F1 equals what? Okay, this distance, we have the total distance, this distance. So this distance equals what? This number minus, assume that this distance is called D. And this distance is called what? 3.9 times 10 to the power 8 minus D. This distance, 3.9 times 10 to the power 8 minus D, which is the distance. Okay? F1 equals what? G capital between Earth and the planet. G or the body. G capital M Earth over this distance, D square. Okay? Equals G capital M moon, M body, M moon over this distance, which equals 3.9 times 10 to the power 8 minus D over power 2. G cancel with G. M of the body cancel with M of the body. Mass of the Earth times رقم ده, mass of the Earth can 6 times 10 to the power 24 times multiplied 3.9 times 10 to the power 8 minus D over power 2 equals mass of the moon times D square. Mass of the moon 7.3 times 10 to the power 22 M mass of the moon D square times D square. تمام؟ Square root to the two sides. Square root of this number. square root 6 times 10 to the power 24 equals 2.5 approximately 2.5 times 10 to the power 12. This number. Multiply this number from by removing square. Multiply 3.9 times 10 to the power 8 minus d equals d, and this number from square root times 10 to the power 22 equals 2.7 times 10 to the power 11. Okay? This number multiply this number minus this number. 2.5 times 10 to the power 12 times 3.9 times 10 to the power 8 equals 9.75 times 10 to the power, the balance party, times 10 to the power 20 minus 2.5 times 10 to the power 12 d equals 2.7 times 10 to the power 11 d. نيجي الناحية الثانية، تمام؟ تبقى بالبلس يبقى 2.7. حتى طبعا لما نكتبها عشان نختصر الوقت بس تبقى ايكوال ده بلس ده، تمام؟ يبقى 9.75 times 10 to the power 20 equals 2.5 times 10 to the power 12 plus 2.7 times 10 to the power 11. هتبقى برضو 2.77 times 10 to the power 12 d. So d equals what في النهاية؟ d equals this number over this number, 9.7 times 10 to the power 20 over 2.77 times 10 to the power 12. 9.7 times 10 to the power 20 over 2.77 times 10 to the power 12. D equals 3.5 times 10 to the power 8 meters. So the distance between this body and the center of the Earth equals 3.5 times 10 to the power 8. طبعا meter. Or we can say 3.5 times 10 to the power 5 kilometer. هي عشان اوريكم في الانسر هتلاقوا الرقم ده مكتوب. Thank you.